A professional services firm in Kuala Lumpur recently published a highly detailed, heavily researched guide for their target clients. They invested significant time and money into making it the definitive resource in their industry. 3 months after going live, that article remained buried on page 3 of the search results. On this split-screen comparison, you can see the anomaly. The firm's dense, long-form guide is locked at rank 30. On the right, a competitor's article, which is a fraction of the length and objectively less detailed, rises straight to rank 1. The standard business reaction to this scenario is to double down on production, write more articles, increase the publishing frequency, and spend more money on content. But if the firm's text is objectively more comprehensive, why is the search algorithm rejecting it while promoting thinner material? The error stems from how we assume machines process information. We write for human eyes, ignoring the structural code an algorithm actually uses to read a web page. Human readers determine a text's importance through visual hierarchy, relying on layout and font sizes. Machine algorithms rely strictly on the underlying HTML syntax to tell them what matters. When you strip away the cascading style sheets, the design elements that dictate color, spacing, and typography, a website is reduced to raw code. Every human-centric visual cue disappears. What remains is the extraction path. This wireframe diagram demonstrates how search crawlers navigate a site, moving through a sequence of nested boxes to determine the actual subject matter of the page. Crawlers do not evaluate text in a vacuum. They calculate the relevance of a paragraph based on the specific HTML tags encasing it. When those structural boundaries are ambiguous, the crawler cannot read deterministically. It is forced to rely on heuristic guesswork to figure out what the text means. Running a technical audit on the Kuala Lumpur firm's failing article uncovers the point of friction. The entire page was constructed using a drag-and-drop builder, wrapping text inside 6 nested div containers. A div tag is a structural void, providing 0 semantic meaning to search engines. Moving through this undifferentiated mass of div tags, the crawler cannot identify the article's boundaries. Peripheral text from the site's menu and footer bleeds directly into the page's topic calculation. At the same time, sidebar widgets and links to unrelated posts inject entirely different sets of keywords into the core text model. This creates a state of signal dilution. The mathematical weight of the primary topic drops severely as it gets mixed with all the surrounding noise on the page. The long-form article failed because the code structure made it impossible for the crawler to isolate the signal. The writing itself was never the problem. The audit also reveals a second major structural failure. The page is missing an H1 tag entirely. The web designer preferred a smaller font size, jumping straight to an H2 tag. But algorithms process heading tags as a cascading map. An H1 tag carries the highest possible topical weight. By prioritizing a visual preference over proper HTML, the page mathematically declared to the algorithm that it lacks a governing thesis. Correcting the extraction path requires swapping those structural voids for precise semantic landmarks. This process requires 0 rewriting. No new content needs to be generated. The fix relies entirely on altering the HTML container tags. We start with the main tag, which explicitly instructs the crawler where the primary content begins. Next, the article tag signals that this specific block is independently meaningful and worthy of indexing. Restoring a strict H1 through H6 cascade rebuilds the topic priority map, providing the algorithm with an organized table of contents it can weight accurately. With these boundaries enforced, the crawler interacts exclusively with the targeted text block. The focus meter locks onto a single subject, ignoring the surrounding noise. Semantic HTML tags serve as deterministic coordinates. They allow algorithms to efficiently partition the document object model and assign precise value to isolated blocks of text. Structural correctness also means managing the peripheral elements of a web page. Navigation menus and sidebars are necessary user features, but they pose significant semantic hazards. The nav tag acts as a containment mechanism, mathematically excluding navigational keywords from the core article. Similarly, the aside tag surrounds promotional widgets, lowering their semantic weight relative to the main content. Proper HTML structure not only defines your most important text, it actively defends your content from being diluted by its own navigational environment. Semantic HTML provides the baseline infrastructure required for AI-driven research and citation. User behavior is shifting from link-based search engines to generative AI retrieval systems like Perplexity, ChatGPT's web citations, and AI overviews. These systems operate as parsers. They must process code structure before they process the text to extract factual claims accurately. An AI system leverages a clean article tag to securely isolate a claim, identify its context, and attribute the author for a citation. By contrast, a page built entirely out of unstructured div tags presents as an undifferentiated block of text, which drastically lowers the AI's confidence score in extracting reliable data. If an AI system cannot confidently isolate your core claims from the surrounding sidebar noise, it lacks the structural certainty required to prioritize and surface your content in its final answer. Returning to the professional services firm in Kuala Lumpur, the outcome of correcting their HTML highlights the severity of this issue. The developer applied proper semantic tags and fixed the heading hierarchy. Without writing a single new word of content, the article moved from page 3 to page 1 within 2 crawl cycles. Business leaders and strategists must demand structural correctness from their developers. HTML tags operate as search signals, not visual formatting tools. Auditing your extraction path is the only reliable way to ensure your website's underlying code isn't actively neutralizing the investments you make in content.